So now what we do is we start practicing the previous year questions from medical entrance, from the JEE and from the JEE advanced. So what I suggest is those people who are new here, please make sure that you go through the previous videos, because those videos are the one which gives you foundation for the practice of these questions. But it doesn't mean that I'll be skipping the steps here, or if I'm not detailing the steps here, I'll be doing the same as in previous videos. But it is highly recommended that you go through the previous videos and then only come back here, because see, that's how the structure of the playlist is designed. It is designed from A to Z. You start from A, you sequentially move to the higher level steps, and then yes, the moment you complete the watching the playlist, the entire playlist, yes, the chapter is complete. It covers almost every aspect from the NCRT. So once again, highly recommended that you go through the previous videos. I think there are 120 to 150 questions being solved. If you solve those questions, then you'll have a concrete foundation about how to solve the upcoming previous year questions. Okay. All right. Now coming to this question. So it says a particle moves in a straight line so that its displacement x is given by x square is equal to t square plus 1. Its acceleration in meter per second square is. It's a very tricky question. It's a very lengthy question. In fact, I would say. See, let's try to understand and solve this question. So what is given is x square is equal to t square plus 1. Okay. Before I take you to the solution, let me clarify a couple of doubts that students much often ask. Shouldn't be a problem for the engineering aspirants, but for the NEET aspirants who focus more on bio and chemistry, unlike engineering where they give more emphasis on maths. So for people who want to understand this concept very clearly, it's very simple. Don't go beyond this. See, it's d by dt of t square is 2t. Okay. I'll add one more example. D by dt of t cube is 3 into t square. But at the very same time, d by dt of x square, if x is not a constant, I repeat, if x is not a constant, is equal to 2x into dx by dt. Again, if x is not a constant, d by dt of x cube is equal to 3x square into dx by dt. Simple. Let's go through that again. So d by dt of t square is 2t. At the same time, d by dt of x square is 2x into dx by dt. D by dt of t cube is 3t square, but d by dt of x cube is 3x square into dx by dt. In which case, if I mark this given equation as equation 1, and if I differentiate with respect to t. Okay, now you may ask me, why do I differentiate with respect to t? See, because if I'm given x, if I differentiate it with respect to time, what do I get? Velocity. If I'm given v, velocity, if I differentiate with respect to time, what do I get? Acceleration. What is being asked in the question is to find out the acceleration. All right. So we'll differentiate this equation. Now, when we differentiate with this equation, we get d by dt of x square is equal to d by dt of t square plus 1. So d by dt of x square is equal to d by dt of t square plus 1. Now have a look at here. It is not d by dx of x square. It is d by dt of x square. In which case, what is d by dt of x square? Is it 2x? No, it is 2x into dx by dt, which is further equal to d by dt of t square plus d by dt of 1. Now, what is d by dt of 2x into dx by dt? See, dx by dt is velocity, so this is 2x into v is equal to, what is d by dt of t square? Is it 2t into dt by dt? No, d by dt of t square is 2t plus derivative of a constant is 0. So we have 2vx is equal to 2t, or we can say xv is equal to t. From which we can write that Okay, so we have xv is equal to t. Let me mark this as equation number 2. Now here you need to understand that both x and v are function of t, which means we have two functions here. How do you differentiate that? Very basic. So d by dt of, say, now let me put this as simple as possible. One function into other function is equal to 1 into derivative of other function plus second into derivative of first function. Simple. So d by dt of first function into second function is equal to first into derivative of second function plus second into derivative of first function. Okay. What is the first function here? X. What is the second function here? V. So if we differentiate this given equation, we get d by dt of x into v is equal to d by dt of t. Now you might be thinking, won't there be a shortcut method to solve this question? We'll discuss upon that too. But as of now, let's focus on the primary method to do this. So what you get is first into derivative of second function, which is v, plus what is the second function? Second function is v into derivative of first function, means into d by dt of x is equal to, what is d by dt of t? It is 1. Now x into, what is dv by dt? dv by dt is rate of change of velocity with respect to time, which is acceleration. So this becomes acceleration plus v into, what is dx by dt? dx by dt is rate of change of displacement, which is velocity, which is equal to 1. In which case we can say that xa plus v square is equal to 1, or a is equal to 1 minus v square upon x, which gives our answer. We have found out the expression for acceleration, but are we done with the question? No. Why? Because we may feel that we have found out acceleration, but none of the answers match. Why? Because all the answers either have x or are a combination of time and x. But in this case, we have acceleration expressed in terms of velocity and x, in which case the answer is not complete. And how do we complete this? We need to complete this acceleration by converting v in terms of x. And how do you do that? See, what is equation number, I didn't name this, so let us name this as, okay, some equation. So xv is equal to t implies, what is v is equal to? V will be equal to t by x, right? So I can change this equation here. What do I get? I can write that a is equal to 1 minus, instead of v, what do we have? T by x. 1 minus t by x, the whole square, the whole upon x. So what is a is equal to? A becomes, let me not skip the steps, 1 minus t square by x square, the whole upon x, which means a is equal to x square minus t square by x, the whole upon x. Now, can we make any further changes here? Yes. See, what is given in the question? The question is given that x square is equal to t square plus 1, which means x square minus t square is equal to 1, right? So if I bring this x square minus t square is equal to 1 in this equation, what do I get? I get a is equal to, instead of x square minus t square, where I can write 1, right? X square minus t square is equal to 1. Yes. And oh, there's a mistake. It's not x, it's x square. So we can write 1 by x square, the whole upon x. So I'll write x as x by 1, right? In which case, what is a by b, the whole upon c by d is equal to a by b into d by c. In this case, it will become a by b, 1 by x square into 1 by x, which is equal to 1 by x cube, right? 1 by x cube. So that gives us the answer to be option A. Now, if you're looking for a shortcut method, you may argue that since it is given x square as t square plus 1, you can write that the okay, so we can write the 2x into v, right? 2x into v is equal to 2t, and then you may say, since velocity is here, the second derivative should have a component of t or maybe a component of a, and then you try to make rough estimates of powers of a and t, which doesn't make sense here. Why? Because x and v are not arbitrary values here. X and v, both of them are functions of time, which means they have to be further differentiated to make sure that no variable or no constant get eliminated. And if such elimination takes place, it may give us a wrong answer, because there is another option which says t square by x cube. So even if you say that there can be a third power of x, you still have two options, 1 by x cube and t square by x cube. So you can't come into conclusion. So it is always better that you spend some more time in solving the question and not search for shortcut always. But yes, what I always suggest to my students is, don't start solving problems in a in a rush and then say that you are solving problems quickly. No, see, how do you solve problems quickly? It should come through it should come to you automatically. And how does that happen? That happens when you keep on practicing similar questions, and you repeat one question time over and over again. That's how you increase your speed. So things should come to you naturally. Now the same question, when you do it in an exam environment, due to that environment, what happens is a kind of rush, we call it adrenaline rush, or any kind of instant hormonal actions, which gives you a push to solve these questions in a much faster way. But since I'm explaining, it will definitely take some time to do. And if you come across any methods which can be used to solve these questions, always make sure that those questions don't let you to false eliminations of constants or variables. Having said so, let's move on to the next question. The motion of a particle along a straight line is described by equation x is equal to 8 plus 12t minus t cube, where x is in meter and t is in second. The retardation of the particle when its velocity becomes 0. Okay. So we need to find out the retardation of the particle. And what is the condition? When the velocity is equal to 0, right? So what is given? X is given. What is x? X is displacement. So from displacement, we need to find out velocity, and then equate this velocity to 0. And then at this time, we need to find out the retardation. Right? This is the workflow. Now, how do you do this? See, what's given is x is equal to 8 plus 12t minus t cube. Now, how do you find out velocity? Velocity v is equal to d by dt of x, which is d by dt of 8 plus d by dt of 12t minus d by dt of t cube. So v is equal to d by dt of 8 is 0, 2t is 2, and d by dt of 3 cube is 3 into 2 square. Oh, it's 12, right? Sorry, so it's 12. Okay. Now, when velocity is equal to 0, right? When velocity is equal to 0, we can write that 12 minus 3t square is equal to 0, which means 12 is equal to 3t square, which means 4 is equal to t square, and therefore t is equal to plus or minus 2, out of which minus 2 doesn't make sense, and therefore t is equal to 2 is what we get. But the question is not to find out the time at which velocity is 0. The question is to find out the corresponding retardation. So when t is equal to 2, what is acceleration? We don't know. But what is acceleration otherwise equal to d by dt of v? Now what is v? V is equal to 12 minus 3t square. So acceleration A will be equal to d by dt of what is v? V is 12 minus 3t square. Therefore, acceleration will be equal to d by dt of 12 minus 3 into d by dt of t square. So, acceleration is equal to d by dt of 12 is 0 minus d by dt of t square is 2t. So, this becomes minus 3 into 2 into t, which is equal to minus 60. So, a is equal to minus 60 and the required time is 2. Therefore, a will be equal to minus 6 into 2 and therefore a is equal to minus 12 meter per second square. So, the correct option is, we have only 12 meter per second square. What you get is minus. Okay, so since it's minus, it means it is primarily retardation in nature, and since the question is asking for retardation, the correct option is option D. A man runs at a speed of 4 meter per second to overtake a standing bus. When he is 6 meter behind the door, the bus moves forward and continues in the constant acceleration of 1.2 meter per second square. The man shall gain the door at time equal to. Okay, see, since that we have discussed relative velocity in detail, wherein we have solved almost, we have used traditional methods as well as methods using relative velocity to solve the questions. I will do the same here. First, we'll try to solve this question using the traditional method, and then we'll try to solve it using the relative velocity. So, let us first assume the case of traditional method here. So, what I'm going to do is, I'm going to draw a couple of diagrams to explain the concept. So let us assume that this was the first position of the man, right? So this is the man, and let us assume this to be the bus. Okay. Now let us first understand the assign the corresponding variables. So this is velocity of man and velocity of bus, and we have distance moved by man and distance moved by bus. Okay, so what happens is, initially the bus is at rest, so initial velocity of bus is at rest. Okay, and here it is, the acceleration is 0, which means this the man is moving with a uniform velocity with of vm. Okay, so what happens after some time? See, so let me mark this as the man's position for reference and this as the bus position for reference. Okay, so after some time what happens is, say for example, the man reaches here, right, and the bus was at rest, but it starts to move forward with an acceleration. So say for example, the bus reached here. Okay, then even after some more time, what happens is, the bus is still moving, but the man has gained access to the bus, right? So I think it would be better if we draw it like this. So the man has now access to the bus. In which case, what is the distance moved by the man? See, the man was initially here. Let me mark that as A. And the man has now traveled this far and he has reached here, which I'll call it as C. Okay. So AC is the distance traveled by man, right? I'll explain it once again. So the man was initially here. He traveled this long to overtake the bus or to reach the bus. So this much distance is AC. And what is AC? What does AC represents? AC represents nothing but the distance moved by the man, which I have denoted here as SM. Now, let us talk about bus. So let us take this position as P, right? So the bus was, this was the initial position of bus because it was standing. So this is the initial position of bus, and the bus has moved so far. It has moved from B to C. So the distance moved by bus is BC. So let me write here that as BC. Now what is BC equal to? We have termed it as to be SB. So BC is equal to distance moved by the bus. Alright. Okay, now let's see. See, AC, we should understand from the figure is nothing but AB plus BC, right? Now, what is AB? See, AB, if you understand here, is the initial position of bus. Sorry, A is the initial position of man and B is the initial position of bus, which means AB is the difference between the initial positions of man and bus, which is given into the question as 6 meters. Once again, A is the initial position of man, B is the initial position of B, which means AB is the difference between the initial positions of A and B. Difference between the initial position of man and bus, and difference between the initial position of man and bus is given according to the question as 6 meter. So we can write that AC is equal to, what is AB? AB is 6 plus BC. Right? Now what is AC? AC is distance moved by man is equal to 6 plus, what is BC? BC is distance moved by the bus. Alright. Now let us see what is AB and SM and SB respectively. See, SM means the distance moved by the man. So what is SM is equal to? SM is equal to velocity of man into t. Why? Because the acceleration of the man is said to be 0. In which case, what do we get? SM is equal to, what is velocity of man? It is given as 4 meter per second. So we have 4 into, we don't know the time, so that is t. Let the time be t. What is SB? What is SB? See, SB is equal to distance moved by the bus. So SB will be equal to, equation is UB into T plus half into UB into T square, right? Now, since the bus was standing in the standing position initially, so UB is equal to 0, which means that term will get eliminated. So what we have is SB is equal to, what is UB? Velocity of the bus, not UB, it should be AB. So what is AB? AB is 1.2 meter per second square. So that becomes 1.2 into t square by 2. Therefore, SB now becomes 0.6 t square. Right? So we have found out SM, we have found out SB. What can we do? We can substitute in this equation. And when we do that, what do we get? What we get is SM, which is 4t. I think it would be better if I write down this equation once again. So I'm writing down this equation once again. So SM is equal to 6 plus SB. What is SM? SM we have found it out as 4t is equal to 6 plus, what is SB? SB is 0.6 t square. Now, if this is the case, what do we have out of this? What we have out of this is nothing but a quadratic equation which looks like 0.6 t square, right, minus 4t plus 6 is equal to 0. So to make this more simple, let us multiply this by 6, 10. So this becomes 6t square minus 40t plus 60. So 0 is equal to, dividing this by 2, what do we get? 3t square minus 20t plus 30. Okay, this is the required equation. And here what we can do, we can find this by x is equal to minus b plus or minus root of b square minus 4ac by 2a. So what is b here? B is minus 20. What is a here? A is 3. And what is c here? Is 90. So what do we get? X is, okay, we'll solve the value of x later. Now let us solve the same question using the method of relative velocity. So when we use relative velocity, what I'm trying to say is, instead of considering the motion of two objects, we will consider one object in motion with the velocity of other and the other being at rest. Some students may find this difficult. If you're not watched the videos on relative velocity, I've explained it in much detail, so you can try watching the videos there. But anyway, I'll just explain the concept here once again. So what I'm going to do is, we have a man moving with initial velocity um and bus with initial velocity ub, right? Which is actually equal to 0, which doesn't matter here. We are just trying to understand the concept here. So what I'm trying to do is, instead of considering both the bodies under motion, what we can do is, we can consider just one object in motion, but this time not his velocity, but his velocity with respect to the bus. Okay, and the distance between them remains the same. So what here we call is, this is umb is what we call as the relative velocity, right? And since there is acceleration here, we consider this object moving with acceleration of man with respect to p. Okay, now the idea will become more clear when you try to understand how the solution is done. So it goes like this. Initial velocity of man is given to be 4 meter per second. Initial velocity of bus is given to be 0, which means since both of them are in the same direction, in relative velocity of man with respect to b is umb, which is equal to um minus ub, which is equal to 4 minus 0. So relative velocity, okay, or else I think it's better we write umb. So umb is equal to 4 minus 0, and umb is therefore equal to 4. Now similarly, all other aspects of the motion will be taken in the relative conditions, which means acceleration of man is equal to, according to the question, is 0. Acceleration of the bus here is given to be 1.2 meter per second square, 1.2. So what is acceleration of man with respect to b? Acceleration of man with respect to b is acceleration of man minus acceleration of b of bus. So a and b will be equal to minus 1.2, right? So we have u, we have a. Now the equations of motion apply to the object moving with relative velocity. What would that be equal to? S is equal to ut plus half at square, but instead of s, what do we consider here? S, relative displacement, remains the same, which umb into t plus half amb into t square. What is the distance between them? It is given in the question to be 6, which is equal to, what is umb? It is 4 into t plus half into, what is amb is minus 1.2 into t square. Now if we try to solve this equation, what do we get? 6 is equal to 4t minus 0.6 t square. So this is equal to 0.6 t square minus 4t plus 6 is equal to 0 is the equation that will give us the solution for the time. Is this same as the previous equation? 6t square minus 40t plus, okay, so 0 is equal to 6t square minus 40t plus 60. Yes, this is the same equation. So this also will give you the answer to the time. So we have solved the one problem in two different ways. So let us now come back to the solution here. So what is x is equal to minus b? What is minus b? 20 plus or minus root of, what is b square? 20 square, which is 400, minus 4 ac. 4 into a is 4 into 3, 12 into c is 12 into 30 is 360. The whole upon 2a, a is 3, so this becomes 2 into 3, 6. So x is equal to 20 plus or minus root of 400 minus 360 is 40, the whole upon 6, right? So 40, I can write it as 2, 20, 2, 10. So x is 20 plus or minus root of 2 into 2 into 10, the whole upon 6. So x is equal to 20 plus or minus root of 4 into root of 10, right? Whole upon 6. So x is equal to 20 plus or minus 2 root 10 by 6. If you divide the whole expression by 2, 20 by 2 is 10, plus or minus 2 by 2 is 1 into root 10 by 6. Okay, now root of 10. So see, 3 square is equal to 9 and 4 square is equal to 16, which means definitely the root is between 3 and 4. So 35 square is 1225. So 3.5 square will be 12.25, which means the value is between 3 and 3.5. Logically, it should be very close to 3.3. So let us take a 31 into 1 is 31. 3 ones are 3. 3 3s are 9. Yes, so 961. So it's approximately equal to 3.1. Approximately. In which case, what is x is equal to? X is equal to 10 plus or minus 3.1 by 6. Now, when we say 10 plus or minus 3.1 by 6, what do we get? X is equal to either 13.1 by 6 or x is equal to 10 minus 6 would be 10 minus 3.1 would be 10 minus 3.1 would be 6.9, right? Oh, sorry, 10 minus 3.1, right? 10 minus 3.1 would be 6.9. So either 6.9 by 6, in which case x is equal to, oh, I made a small mistake here. This is not 6, right? Instead of 6, it should actually be 6 by 2 is 3. So it should be 3 here. 3. Here also it is 3. So we have 3.1 by 3, which gives the value to be either 13.1 by 3. So that will be somewhere around 13.1, 4 3s are 12, 4.3 this are 9, 11 minus 9 is 2, okay, 4.3, or x is equal to 3 2s are 6, 9 3s are 9. So we get two values, x equal to 4.3 almost, and x equal to 2.3. And what is x here? X is time, right? So we get the value of t is equal to either 4.3 seconds or it is equal to 2.3 seconds. Let us look at the option now. Okay, so well, actually this question is a bit confusing in terms of option, because both options are given here and both of them should ideally be correct. Now if you ask me the explanation for both of them, why both of them are correct, I'll give you the picture clarity for that process too. See, so here is man, so this is man and this is bus, right? So when we say there are two possible values of time for man beating the bus, it simply means that since the bus is having some acceleration and the man is going in uniform velocity, at some point of time here the man will beat the bus, right? And after that, what happens is the bus is still having acceleration, the bus will move forward and the man will now be back in the will be behind the man. After some time, so this is bus again and this is man again, and after some time what will happen is the man will again overtake the bus. So this is the possible explanation for we getting two values of time. A stone falls freely under gravity. It covers distances h1, h2, and h3 in the first 5 seconds. The next 5 seconds, see, this is the question what we were doing in a separate playlist with the title problems based on ratios, right? So I think this is the last problem in that playlist. And it is essentially the same question. So let me start explaining the solution, but before that let us try to visualize the concept. See, so what's given here is an object is dropped So it covers, it is dropped, it's a stone falls freely under gravity, it covers distances h1, h2 and h3. Okay, so what is given is, in time t1, say the body covers h1 distance, all right, and in the next t1 seconds, the body covers distance h2, and in the next t1 seconds the body covers a distance h3. Now you may ask me, why is the distance increasing? The concept is very simple, because as the body is dropped, as it is under the influence of acceleration due to gravity, what happens is the velocity keeps on increases for equal intervals of times. If the velocity increases, then the distance traveled will correspondingly increase. It's the concept. Now, so I think it's better to name these points for better clarity. So let's say this is O, A, B and C. Now, okay, now let us make use of the displacement. Let us make use of the displacement time relationship, right? So we have displacement time relationship. Displacement time relationship. What is happening with the pen? Yeah, okay. Displacement time relationship. What is it equal to? S is equal to ut plus half at square. Since it is dropped from rest, u is 0. So this becomes S is equal to half at square, right? So this is the primary equation that we are going to use here. Now how are we going to apply this? See, it goes like this. The first distance traveled is h1, which will be equal to half into a here is g and t square is t1 square. Okay, since we are given first 5 seconds, we can write h1 is equal to half into, let us take g into 5 square. So h1 is basically 5 into 5 square, right? Okay, now what is h2? See, h2 is the distance covered in the next t1 seconds. So h2 is half into. So here we need to understand one thing, which is the amount, sorry, the duration of ball or the object in the air. See, when the object had covered distance OB, right? When the object has covered distance OB, what we need to understand is the time was t1 plus the next t1, right? Or which is 2t1. And here, since t1 is 5, this is 2 into 5, which is 10 seconds. So when object was in OB, it is half into g into 10 square. So I'll write OB is equal to half into g is 5. So we can add 5 into 10 square. Similarly, what is OC? OC is the distance traveled by the object when it was in air for t1 plus t2 plus t3. Right? Sorry, t1 plus t1 plus t1 square. I repeat, OC is the distance traveled by the body when the object was in the air for t1 plus t1 plus t1 seconds. I'm sorry, I think I said t1 square earlier when I said this. So I'll correct it once again. So what is OC? OC is the distance traveled when the object was in air for t1 plus t1 plus t1, which is 3 t1 seconds, right? So what is OC? OC will be equal to half into g into, instead of t, we can write 3t1 the whole square, right? So OC further becomes, OC is equal to 5 into, what is t1? T1 is 5. So this becomes 15 square, right? Now OB is equal to 5 into 10 square, and OC is equal to 5 into 15 square. Now what is OB? See, from the diagram, OB is H1 plus H2. So we have H1 plus H2 is equal to 5 into 10 square, which is 5 into 100, that is 500. And what is H1 from here? H1 is 5 into 25, which is 125, right? So if you subtract these two equations, what do you get? H1 plus H2 minus H1 is equal to 500 minus 125 is 573, right? Yeah, 375, which means H1 is equal to 375 and H2 is equal to 375. And what is H1? H1 is equal to 125. Okay. Now what do we have? Okay, we have OC. So OC from the figure is H1 plus H2 plus H3. So that we can write it as H1 plus H2 plus H3 is equal to 5 into 15 square is 225. Okay. So what is H1 plus H2 is equal to? H1 plus H2 from this equation is 500. So we have 500 plus H3 is equal to 5 into 225. So what is H3 is equal to? 5 into 225 minus 500, which is 5 into 100. So H3 is equal to 5 into 225 minus 100, right? So H3 is equal to 5 into 225 minus 100 is 125. What is 125? 125 is H1. So we can write that H3 is equal to 5 into H1, or otherwise H1 is equal to H3 by 5, right? So we got H1 is equal to H3 by 5 is an option which says that, okay, H1 is equal to H3 by 5. Similarly, we can find out H1 is equal to H2 by 3. See, what is H2 is equal to? H2 we have found out to be, what's value of H2? H2 is 375, right? H2 is 375. So I'll write H2 is equal to 125 into 3, right? What is 125? Sorry, 125 into, wait, am I making any mistake here? 75, yeah, okay. So what is 125 is equal to? 125 from the question is H1. So H2 is equal to H1 into 3, in which case what is H1 is equal to? H1 is equal to H2 by 3. And therefore H1 is equal to H2 by 3, and H1 is equal to H by 3 is the required value, which makes the correct option as option D. The displacement of a particle of mass m moving in one dimension under the action of force is given by t is equal to root x plus 3. The displacement of the particle when its velocity is 0 will be. Okay. So what's given is t is equal to root x plus 3. We can write that root x is equal to t minus 3. What have we been asked to find out? The displacement of the particle when its velocity is equal to 0. Okay. So if I square this equation, what do I get? Root x the whole square is equal to t minus 3 the whole square, which means x is equal to t minus 3 the whole square. If x is equal to t minus 3 the whole square, if I differentiate this equation 1 with respect to t, what do I get? D by dt of x is equal to d by dt of t minus 3 the whole square, right? So what is d by dt of x? It is v. So we have velocity v is equal to 2 into t minus 3 the whole raised to 2 minus 1 into d by dt of t minus 3. So we have v is equal to 2 into t minus 3 raised to 1 into what is d by dt of t? It is 1. What is d by dt of minus 3? It is 0. So you have v is equal to 2 into t minus 3. But what is the question? The question is not to find the velocity. The question is to find the displacement when the velocity is equal to 0. So we can say when v is equal to 0, we can say that 2 into t minus 3 is equal to 0, which means t minus 3 is equal to 0, which means t is equal to 3, right? So when t is equal to 3, what is the displacement? We need equation 1 here. So displacement x is equal to t minus 3 the whole square. So x at t is equal to 3 is equal to t minus 3 the whole square. So x is equal to 3 minus 3 the whole square, and therefore x is equal to 0, which means it is not that the distance traveled is 0, it is the displacement is equal to 0. That means the mass has returned to the initial position, thereby making the displacement to be 0. Okay, so the correct option is option B, 0 meter. A 100-meter long train is moving with uniform velocity of 45 km per hour. The time taken by the train to cross a bridge of length 1 kilometer is. It would be better if you try to visualize the question first. So let us take two conditions. So let's write before crossing the bridge, and after crossing the bridge. So let us say this is the bridge, okay, and this is the road or the rail. This is the rail. And the train is, I'm not going to take the exact values here. Let me just write length of, it says train, right? So length of train is, say, LT. LT is length of train, okay? And what is this much distance? It is length of bridge, say LB. Okay, now what happens after crossing is, I think to make more sense, should make a small rearrangement here. See, right before the train has started to cross, right, this is how the train would look like. So this is length of train. Now after crossing, what happens is, after crossing, the train has completely moved over the bridge, right? The completely train has moved over the bridge. So it was earlier here. It slowly moved like this, and then it's covered the entire bridge. Now, how much is this distance? This is length of the bridge. And how much is this distance? It is length of the train, right? So the train was in this position when it has passed the bridge, or when it has crossed the bridge. It is not the initial initial line that it should pass. The train should pass. Okay, let me make a reference here so the things will become more clear. So if you say bridge is B1, B2, and train is T1 and T2, okay, T1 and T2, only when the T2 portion coincides with the B2 portions, or do I choose a better naming? That would be fine, right? Okay. Oh, that's the name. Okay. So when the final portion of the train, which is T2, coincides with the final portion of the bridge here, which is B2, only then the crossing is complete, right? So crossing completes when T2 overlaps with B2, which happens in this case. When T2 overlaps with B2, what we get is a straight line, B1, B2, T2, T1, T2, right? B1, B2, T1, T2. So the whole distance becomes B1 to T2. So the whole distance B1 to B2 can be written, or can be drawn as like this. It can be drawn as, right? So this is length of bridge and this is length of train. In which case, what is distance traveled by the train? In which case, distance traveled by the train would be equal to LB plus LT, right? So I'll write it as S of T is equal to LB plus LT. What is LB? This length of bridge is given to be 1 kilometer. Okay, units are not matching, so let us use, since it is second, we'll convert all to meter per second. So let us make 1 kilometer meter. So it is given to be 1 kilometer plus what is length of train? Train is given to be 100 meter. So distance traveled by the train is 1 kilometer, which is 1000 meter plus 100 meters. So length traveled by train is 1100 meter. Now, if that is the case, what is the velocity given? Velocity of the train is given to be 45 kilometer per hour, right? And what is 1 kilometer? 1 kilometer is 1000 meter. What is 1 hour in terms of seconds? It is 3600 seconds. So velocity of train basically becomes 45 into 0 and 0 will cancel. So 45 into 5 by 18, right? Which is 5 5s are 25, 5 4s are 20 plus 2 is 22. So we get 225 by 18. So velocity is 225 by 18, 225 by 18 meter per second. Now what is that we are supposed to find out is the time taken. See, so time taken would be equal to distance by speed. What is distance? Distance is st. What is speed? Speed is vt. So st is 1100 whole upon speed is 225 upon 18. So this becomes 1100 into 18 the whole upon 225, right? which is equal to, so if we write down the numerical once again, so 1100 into 18 by 225, right? Okay, so 9 2s are 18, 9 4s are no 9 2s are 18, 22 minus 8 is 4, rest is 5, 45, 9 5s are 45, so 2 by 25. So 1100 by 25. So this becomes 5. 5 2s are 10. 5 2s are 10. So this becomes 220. Right? So 220 by 5 is 5 4s are 20. 20. 5 4s are 20. So 44 into 2 now becomes 88, which means the correct option is 88 second, option C. And I think I should add one more point here. See, that was not, I think the diagram was a bit confusing, so I would like to rephrase the diagram. So it goes like this. This is the train, right? And let's assume this to be the bridge. Okay, train and bridge. So this is the point of initiation of crossing, right? So after crossing, what happens is the bridge is stationary, but the train has now moved past the bridge, right? So this is the train. So if you analyze the initial position of train, it was here, and the train has moved this far. So what happened is the train has moved this much distance. So I'll make this O, and let us choose say Y, and this to be X. So the distance traveled by the train, I repeat, the distance traveled by the train is basically OY, right? So OY is this distance, this complete distance. Now what is OY? OY is OX plus OY. What is OX? OLXT, which is OX is length of train. What is XY? XY is this value here, which corresponds to B, which is length of bridge. So what is OY is equal to? OY is equal to LT plus LB. What is OY? OY is the distance traveled by the train. So distance traveled by the train is length of train plus length of bridge. I think now it becomes more clear to understand. If it is not, please do mention it. I'll make sure that I present a better diagram with a more conceptual understanding. The distance x of a particle moving in one dimension related to the time t into root x plus 3. Oh, it's t is equal to root x plus 3. Find the displacement of the particle when its velocity becomes 6 meter per second. Okay, so very similar question to the one that we did a couple of sessions ago. So it goes like this. T is given to be root of x plus 3, right? In which case, let me express this in terms of root x. So root x would be, so say t minus 3 is equal to root x. If I square this equation 1 on both sides, what do I get? T minus 3 the whole square is equal to root x square, which further gives me t minus 3 the whole square is equal to x. Now, if t minus 3 the whole square is equal to x, what we can do is we can differentiate this on both sides. So we get d by dt of t minus 3 the whole square is equal to d by dt of x. Now what is d by dt of x? D by dt of x is velocity. So if d by dt of x is velocity, this becomes 2 into t minus 3 into d by dt of t minus 3. What is d by dt of t minus 3? See, d by dt of t minus 3 is d by dt of t minus d by dt of 3, which is equal to 1 minus 0. So this reduces to 2 into t minus 3 into 1 is equal to v. So we have 2 into t minus 3 is equal to v. So when the velocity becomes 6 meter per second, 2 into 3 minus 3 is equal to v becomes 6 seconds. So when 2 into 3 minus t minus 3 is equal to 6 seconds, t minus 3 is equal to 6 by 2, which is 3. So t minus 3 is equal to 3 seconds, and therefore t is equal to 3 plus 3, which is 6 seconds. What is the question? The question is to find out the displacement. What is the displacement? Displacement is x is equal to t minus 3 the whole square. So x is equal to, what is the value of t? The value of t is 6. So this becomes 6 minus 3 the whole square. So x is equal to 6 minus 3 is 3 square. So x is equal to 9 meters. So the correct option is option A. A particle of unit mass undergoes one-dimensional motion. Velocity is equal to, see, it's actually v of x is equal to beta x the whole to the power minus 2n. Well, beta and n are constants. The acceleration of the particle as a function of x. So let us start the question by writing down what is given. So what is given is v of x is equal to beta x the whole to the power minus 2n. Now, differentiating both sides with respect to t. So what we get is dv of x by dt is equal to d by dt of b. Okay, that doesn't make sense. Okay, all right. So what we'll do here is, we will differentiate this equation with respect to x first. Let's see. So we have d by dx of v, or to be more precise, v of x is equal to d by dx of beta x the whole to the power minus 2n. Now, d by vx of dx is equal to d by dx of beta x the whole to the power minus 2n will be equal to minus 2n into beta x whole to the power minus 2n minus 1. Why? It's simple. So it goes like this. D by dx of x to the power n is n into x to the power n minus 1. So instead of n, we have here minus 2n. Instead of x, we have beta x whole raised to minus 2n minus 1. Now, what we need to keep in mind is that we've been asked to find out the acceleration, and we don't have, this is not equal to acceleration. Why? Because acceleration is equal to dv by dt and not dv by dx. Then what is the method to approach to find out acceleration? See, acceleration is nothing but d by dt of v, which I'll write it as dv by dt like this, and then I'll multiply dx like this, right? So what do we get? dv by dx into dx by dt. Is dv by dx familiar? Yes, because we just found it out. dv by dx to be minus 2n beta x the whole to the power minus 2n minus 1. Let me take you to the process again. What is acceleration? A is equal to d by dt of v. which is dv by dt. And how did I rearrange dv by dt? I wrote dv first here, dt here, then I multiplied it with dx and dx. So dx by dx into dx is 1, so it remains the same. Now dv by dx, we already have found out dv by dx here. So this is dv by dx, right? So this is the value of dv by dx. But what is interesting is to know that what is dx by dt? So dx by dt is nothing but velocity. So this becomes minus 2n into beta x whole to the power minus 2x minus 1 into what is velocity? Velocity is v of x as given in the question, which is beta x whole to the power minus 2n. So acceleration A is equal to minus 2n into, if you consider this as A and if you consider this as A again, so what we have here is a raised to m into a raised to n, which is nothing but a raised to m plus n. So what we have here is minus 2n into beta x the whole raised to minus 2n minus 1 plus minus 2n. And what is that is equal to? So acceleration is equal to minus 2n into beta x the whole to the power minus 2n is minus 4n minus 1, which is the answer we require. So minus 2n beta x minus 4n minus 1, which is minus 4n minus 1, option A. See, the question appears, it appears really simple, but if you forget this step, or maybe if you just try it as I did earlier, if you try to solve this question using d by dt, it may consume some time to realize that it is not the way that you should do it. So how does that correction comes to you? It comes to you naturally. Okay, so it comes through practice basically. So that's how we solve this question. Let us now move on to the next question. Car starts from rest and accelerates uniformly to a speed of 180 km per hour in 10 seconds. The distance covered by the car in the time interval is. See, these kind of questions are, I would say, these are really outdated. Even in 2015, it would have been a substandard question. These kind of questions don't usually appear for NEET, never for JEE mains and advanced. Advanced, I mean, it really doesn't make sense talking about the exam with this level of questions. But I would say it is these kind of questions which would give you confidence in learning the subject. You know, this I would say this serves as a boost to your numerical skills, which is the most important thing which a student should acquire while trying to solve MCQs. Okay, so let's now start solving the question. So what is given here is it starts from rest. So we can say that u is equal to 0 and accelerates uniformly to a speed of 180 km per hour. So in 10 seconds. So t is given to be 10 seconds. And uniform acceleration, the velocity is 180 km per hour. So we'll convert 180 km per hour into meter per second. So this is kilometer per hour. So how much is 1 kilometer in terms of meter? It is 1000 meters and hour is 3600 seconds, right? So this becomes meter per second. So basically what we get is 180 into these two zeros will cancel. So what we get is 180 into 10 by 36 meter per second, which is 18 2s are 36. What left is 100 by 2. So what you get is 50 meter per second is the final velocity. All right. The distance covered by the car in this time interval is the question. Okay. Now we know that the distance covered is S is equal to ut plus half a t square, right? So we need to find out S is equal to ut plus half a t square. Do we have t? Yes. Do we have u? Yes. Half a into t square. Okay. So S is equal to Okay, do we have A? No, we don't have A. So we have S is equal to half A into T square. All right. Now what is A? See, V is equal to U plus AT, right? So what is A from this? A from this is V minus U by T. So I'll write it over here. So we have half into T square into, what do we have in place of A? It is V minus U by T. In which case, what is S is equal to half into, what is the value of V? Let me just highlight those values for easy. So we have U here, T here, V as meter per seconds. All right. So what is V? V is 50 meter per second minus U is 0. What is time? Time is 10 seconds into T square is 10 square. So this becomes half into 50 minus 10 is 40. 40 by 10 into 10 square. So 40 by 2 is 20. 20 into 10 square by 10. 100 by 10 is 10. So this is equal to 200. In which case the distance traveled with this given conditions of motion is equal to 200 meter, which makes the correct option as option A. The velocity time graph for two bodies A and B are shown in figure. Then the acceleration of A and B are in the ratio. Okay, are in the ratio is the question. Okay. So what we need to understand here is been given two graphs, straight line graphs, right? One which represents the motion of body A, the other which represents the motion of body B. So it's a very simple question. All what we need to understand is the fact that slope is calculated with respect to the angle measured. Sorry, slope is calculated to the angle measured with respect to that of the positive x-axis. So this angle theta A and this angle theta B, right? So we have theta A and theta B, which will represent the slope of the graph. All right. In which case the y-axis is V, the x-axis is t. So what is slope of the VT graph represents? Slope of VT graph will represent change in velocity by change in time, which is basically acceleration. Okay. Now let us see the slope of. So slope of graph of A is equal to tan of angle theta made with the positive x-axis, which here is tan of theta A. Now what is the measure of theta A according to the question? According to the question, theta A is given to be, this much angle is given to be 25 degrees. So this becomes tan 25 degrees. Similarly, what is slope of graph of P is equal to tan of theta, which is made with the positive x-axis, which is equal to tan theta B, which means we need to use theta B, but what is given in the question is not theta B, it is given this angle, right? So this angle is given to be as 40 degrees. So if you reduce the diagram, so this is the graph for B, this much angle is 40 degree. So this is the required angle what we want. So the complete angle is 90 degree, which means this angle is 50 degree. Therefore theta B is equal to 50 degree, in which case this becomes tan 50 degree. So the correct option would be tan 25 to tan 25 to tan 50. Two cars P and Q start from point at the same time in straight line, and the positions are represented by XP is equal to AT plus. Okay, I'll write down the correct question. Meet square, and QT is FT minus T square. At what time do these cars have the same velocity? Okay. So let me first write down those two given displacement time relationship. So we'll be given XP is equal to AT plus BT square, and we have XQ is given as FT minus T square. Right. Now, what is VP? VP would be d by dt of XP. And what is VQ? VQ would be d by dt of XQ. Why so? Because we know that velocity is rate of change of displacement, right? So what is VP? So VP is equal to d by dt of what is XP? XP is given as AT plus BT square. How do you differentiate this? This is d by dt of AT plus d by dt of BT square, which is equal to A into d by dt of T plus B into d by dt of T square, which is further equal to A plus d by dt of T square is 2T. So this becomes 2BT. So what is VP? VP is equal to A plus 2BT. Now, if VP is equal to A plus 2BT, let us now find out what is VQ. So VQ is similarly equal to d by dt of what is XQ. XQ is given as FT minus T square. So what is VQ further equal to F into d by dt of T minus d by dt of T square. So VQ is equal to F minus 2T is the next value that we need, which is VQ. Now according to the question, at what time do the cars have the same velocity? So when they have the same velocity, we can say that VP is equal to VQ, right? So what is VP? It is A plus 2BT. What is VQ? It is F minus 2T. So I'll bring F to the left hand side. So A minus F is equal to minus 2BT minus 2T. So A minus F is equal to, if I take T common here, so what do we get? Minus 2B minus 2T. So T would be equal to A minus F by minus 2B minus 2, or this can be written as multiplying the numerator and denominator with respect to 1. So this becomes F minus A by 2B plus 2, which can further be written as, so we do have an option like that? No, okay. So T can further be written as F minus A by, if we take 2 common, this becomes 2 into B plus 1, which makes the correct option as option D. Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. On the other days, if she remains stationary on the moving escalator, then the escalator takes her up time t2. The time taken by her to walk upon the moving escalator will be. So these are ratios. Okay. So before solving this question, let me first draw a couple of diagrams. Well, actually, 3 diagrams to explain the concept clearly. Now let us say this is the escalator. Okay, so this is the escalator, and the length of the escalator is say, is there given any value in the question? No. So let us say it is S. Okay, so this much distance is S. This much distance is also S. Okay. Now, let us try to understand the given aspects of the question. She walked up the stationary escalator in time t1. Okay. So let us first assume that there is a person standing here, right? And the person is moving. Eventually, the person reaches the final point. Okay. So the same story repeats here too. The person is standing here, is moving, and he reaches the final point. The person reaches the final point. Now, let me denote the velocity of the person with the term Vm and velocity of the escalator with Ve. So velocity of escalator is Ve, velocity of person is Vm, or it is Preeti, right? So it is called Vp for better clarity, Vp. So we have Vp as the velocity of person, and velocity of escalator is Ve. Now, in case 1, what is the value of Ve plus Vp is equal to? See, Ve plus Vp in case 1 is equal to Vp alone. Why? Because the question says that she's walked up on the stationary escalator, which means value of Ve is equal to 0. Okay. Now, in this case, what is distance traveled is equal to? Distance traveled is equal to velocity into time, right? What is the distance? The distance traveled is S. What is the velocity? There is only one velocity, which is Vp. So Vp into time. It is said in the question that the escalator takes up in time t1, right? So this is first relationship. Okay. So we got one relationship. S is equal to Vp into t1. All right. Now in the second case, what is the equation again? Velocity of escalator plus velocity of person is equal to, see, if you understand the second statement, it says that if she remains stationary, which means if Vp is equal to 0, then the only component of velocity, velocity acting is velocity of escalator. Again, this escalator is moving with some velocity, so it will cover some distance. So distance is equal to velocity into time. And what is the distance here? The distance remains the same, which is s, and is equal to, so I think I would use this arrow. So here what it denotes is the escalator is moving, and here the person is moving. In the second case, the escalator is moving, and in third case we have both escalator as well as the person moving. Okay, so the distance will be equal to velocity into time. What is the only velocity here? VE, which is velocity of escalator, into time. It is given that it takes up in time t2. So what we get is VE into t2. All right. So let us highlight that part also. Now, if we try to understand the third part, what is the velocity, or let me introduce, let me say V net in every case. So V net is equal to sum of two velocities, right? So V net is equal to VE plus EP in every case. Similarly, what we can say is V net in this case is equal to VE plus VP. But are any of them 0? No, because it says that the time taken by her to walk up on the moving escalator. So moving escalator means VE is not equal to 0, and walk up means V of person is not equal to 0. So both of them have a velocity. In this case, what is distance is equal to? See, distance here will be equal to velocity into time. So what is distance? Distance now again remains the same. S is equal to, what is velocity? Velocity is V net. And do we know the time? We don't know the time. Let us say time. Okay, let us put time of both, or let us say the time t is equal to. Okay. Now, what is V net? V net is VE plus VP whole into t. Now, what is the value of VE and what is the value of VP? See, from the first equation, what is VP is equal to? VP is equal to S by T1. So here we can write this as VP, right? VP is S by T1. Similarly, from the second equation, what can we write? VE is equal to? VE is equal to S by T2. So here we can write S by T2. The whole into T is equal to S. So now if you divide the entire equation by S, what do you get? So this is the equation we have. So if you divide the entire equation by S, so you get S here, T2 into S here, T1 into S here. So what you get is 1 is equal to 1 by T2 plus 1 by T1 into T, right? So we need to make use of that equation again. So 1 by T will be equal to 1 by T2 plus 1 by T1. So 1 by T will be equal to T1 plus T2 the whole upon T1 T2, in which case what is T is equal to? T1 T2 the whole upon T1 plus T2, which means the correct answer is option B. Now I would suggest that we try to understand the question in a better sense by actually considering an example, a practical example. Say okay, let us consider 3 examples here also. Say 3 cases here also. Case 1, case 2, and case 3. There's a person standing. There's a person standing. There's a person standing. In the first case, only the person moves. Second case, only the escalator moves. And in the third case, both the person as well as the escalator moves. And for a reference, let us take the velocity of person to be 5 meter per second and velocity of escalator to be 2 meter per second. Okay. And let the length of the escalator be 10 meter, right? In which case, okay, so this doesn't make sense, because the first case is that the escalator is stationary. So we have Vp and Ve. So V here is equal to 0. Second case, what happens is the person is stationary. So Vp is 0. And say the escalator is moving with 2 meter per second. The distance remains the same here, 10 meter. But what's conceptual to understand is that in the third case, the escalator is moving with 2 meter per second, which definitely means that the velocity of any person standing still, I repeat, the velocity of any person standing still on the escalator would be 2 meter per second. But in this case, the person is not standing still, he is walking along the escalator, which means here what will happen is the person will give an additional component of velocity, and therefore the person will feel both some velocity is being added, his velocity on top of the velocity of the escalator. So this is the fundamental concept to understand. Just if you ask me, the takeaway lesson from this is to understand that when a object is moving and if a person is stationary on that, I think I can explain that diagram again. So this is a moving object, say velocity is with VO, and if a person is standing still here, velocity of the person will be equal to velocity of the object, no doubt about it. Now, when this is a moving object and it's moving with velocity VO, and when the person is moving within the object with velocity Vp, the net velocity what this person will feel will be equal to Vp plus V0. Okay, so in this case, again the displacement remains the same, which is 10 meter. Okay, so what is time here? T1 would be equal to 10 by 5, which is 2 seconds, right? So if the person walks on the escalator, he will on the stationary escalator, he will take 2 seconds to complete the motion. Okay, now what is T2? T2 means 10 by velocity of escalator alone, which is 2 seconds. So if the person is standing still on the escalator, only due to the presence of him being the escalator, he'll attain a velocity which is the velocity of the escalator itself, and it will take him 5 seconds to reach. But when he is moving along with the escalator, what happens is the T2, or say T is equal to, here becomes 10 by, it becomes 5 plus 2, which is 10 by 7. Well, in this case, it's 1.10 is 1.3, so 1.4 seconds, right? So what is the inference? The inference goes like this. If he moves on his own, he takes 2 seconds. If he moves with the help of escalator, it goes for 5 seconds. And when he moves along with the escalator, he takes less than that time as taken by him on moving alone, which explains the concept that the velocity is being added when he is moving on a moving object. Well, I think this explanation is too deep. It is too basic. I've made it as elaborate as possible, because at times simple things do take more time to explain. Having said so, let's move on to the next question now. A body is freely falling under gravity. The distance is covered by the body in the first, second, and third minute of its motion are in the ratio minute. Okay. So a body is falling under free fall. It is starting from rest. Okay. The time intervals are first minute, second minute, and third minute. So which formula do we take? Do we take S is equal to ut plus half at square? No, what we take is Sn, which is the displacement in the nth second or nth minute or nth interval of time, which is first, second, and third, right? So the formula what we use is Sn. So if the other way around, if it was given that at t is equal to 1, at t is equal to 2, at t is equal to 3, then we'll have used S is equal to. But here we'll use Sn. And what is Sn is equal to? Sn by formula is equal to u plus a by 2 into 2n minus 1. Now, what is the value of u? U, since the body is falling from rest, it is equal to 0. And what is the value of a? Since the body is under acceleration due to gravity, the value of a is g. So we have Sn is equal to g by 2 into 2n minus 1. Let us take g as 10. So Sn will be equal to 5 into 2n minus 1. So this is the general formula. Sn is equal to 5 into 2n minus 1. Now, when Sn is equal to 5 into 2n minus 1, what is distance covered in the first second? Distance covered in the first second is Sn at n is equal to 1, which is equal to 5 into 2 minus 1, which is 5 into 1 equal to 5. Now, what is distance covered in the second second? Distance covered in the second. Oh, my bad. It's not second. It's according to the question. It is minute, right? So second minute covered in the second minute. Would be equal to Sn when n is equal to 2, which is equal to 5 into 2 into, instead of n we will write 2 minus 1, which is 2 into 2 is 4, 4 minus 1 is 3, 5 into 3 is 50. Now the distance covered in the third minute is equal to Sn at n is equal to 3, which is equal to 5 into 2 into 3 minus 1, which is equal to 5 into 3 into 2 is 6, 6 minus 1 is 5, so you get 5 into 5 equal to 25. Now we've been asked to find out this ratio. So what is the ratio? The ratio is S1 to S2 to S3 is equal to 5 is to 15 is to 25, which is equal to 1 is to 3 is to 5, which makes the correct option as option C. A ball is thrown vertically downward with a velocity of 20 meters per second from the top of a tower. It hits the ground after some time with velocity of 80 meters per second. The height of the tower is. See, those who have followed the playlist where I have given specifically problems based on projecting a body from a height. I think I have covered almost every aspect of the problem solving there. So what's given in the question is that a body is projected here, which means there is a velocity u, which is, according to the question, is 20 meters per second. It travels down, it hits the ground with the velocity, say v is equal to 80 meters per second. We've been asked to find out the height of the tower. And how do we do that? It's a very straightforward question. See, we know by equation of motion v square minus u square is equal to 2 into a into s. In this case, we have v square minus u square is equal to 2 into, since the body is falling downwards, acceleration due to gravity, g acts. So we have 2 into a, g into s, and s here will be the distance traveled by the body, which is apparently the height of the tower also. So this will be equal to h, in which case what is h is equal to? H is equal to v square minus u square by 2g. So h is equal to 80 square minus 20 square by 2 into g is given to be taken as 10. So 80 square minus 20 square is 80 plus 20 into 80 minus 20. What I have done is I have taken a square minus b square as a plus b into a minus b, the whole upon 2 into 10. So what we get is 80 plus 20 is 100. 180 minus 20 is 60. The whole upon 2 into 10. So this will get cancelled. We get 2 into 5. So we have 50 into 6, which is equal to 300. Is there option? Okay, so the correct option is option D. The car starts from rest and accelerates at 5 meter per second square at t is equal to 40. It's at t is equal to 4 seconds. A ball is dropped out from a window by a person sitting in the car. What is the velocity and acceleration of the ball at t is equal to 6 seconds? So what's given here is, if we try to visualize this, it's a straight line, a road here, okay, and a car is moving. So this is at t is equal to 4 seconds. Move like this. Here this is at t is equal to 6 seconds. Okay. Now the car is starting from rest, so we can say that u of car is equal to 0 and a of car is given to be 5 meter per second square. 5 meter per second square. Additionally, what's given is a stone is dropped, right? So see, when the stone is dropped, it is still inside the car, right? Which means velocity of stone would be equal to the velocity of the car. So u of stone is equal to velocity of the car, which is, let us say v of car. Okay, at what time it has been dropped? V of car at t is equal to 4 seconds. So I hope this much point is clear. In fact, this is the only concept here. Oh, well, actually there's one more concept which comes with projectile motion. So the basic concept is that since the object is moving along, since the car is moving, the object when dropped from the car will have the same velocity of that as that of the car. Okay. Now, what we need to understand here is, when the object is dropped, it will have the velocity of the car alone. But, so let us say, so this is how, when the object is dropped. Now, as the car leaves and as the stone is on its own, it has a velocity which is offered by the car, yes, which is along the x direction. But the moment it leaves the car, what happens is it will be pulled down by acceleration due to gravity, which means there will be a component of vertical velocity as well. Which means, though the car has moved this direction, the object will now actually follow a projectile motion. Object will follow a projectile motion. And it is almost like this. The stone would trace its path. Which means at every instant, the stone will now have, or the object will now have, two components of velocities. One, uy, and the other would be ux. One would be ux and the other would be uy, right? So every point of time, the object will have two different velocities, one along the horizontal direction and the other along the vertical direction. Now, what are we discussing now? See, it means that velocity of the stone when being dropped, or the initial velocity of stone will be equal to v of car at t is equal to 4 seconds. So at this point, the object has a velocity ux, which is v at t is equal to 4. V at t is equal to 4 of what? Of the car. Let us first find out that. So for the car, we can say that v is equal to u plus at. So v of car will be equal to u of car plus a of car into t at t is equal to 4 seconds. So what is Vc is equal to? Vc is equal to, since it starts from rest, uc is 0. Acceleration of the car is given to be 5, t is 4. So velocity of car is 20 meter per second. Now when the velocity of car is 20 meter per second, what does it mean? It means that the ball is dropped with a velocity of 20 meter per second. Now at this point of time, this 20 meter per second is acting along the positive x-axis, which means ux of the car, sorry, of the ball, ux of the ball is equal to 20 meter per second, right? So now we'll discuss only about the ball. So for the ball, we can say that there are two coordinates, right? One is the x coordinate and the other is the y coordinate, because it has two components of velocity, x component of velocity and y component of velocity. So there will be both velocity along x component, velocity along y component, acceleration along x component, acceleration along y component, displacement along x component and displacement along y component. So we'll write those first. So what are the different velocities? So we have initial velocity as ux, final velocity as vx, initial acceleration along the component as ag, and displacement as sx. Corresponding for the ball in the y component, we have initial velocity in the y direction uy, final velocity as vy, acceleration along the component is ay, and displacement is sy. Okay. Now if we write down the equations of motion for the x component alone, what is v is equal to u plus at? For the y component alone, what is v is equal to u plus at? Let us be more specific. What is vx is equal to ux plus a into t? What is vy is equal to uy into a into t? Now this complete component, the complete x component, is offered by whom? This is offered basically by the moving car. And this component, the entire component of y, is offered by which component? This is offered by the gravity. Now since the car is moving with uniform acceleration, what can we say about the value of ax? Ax will be equal to 0. We just found out that the value of ux is equal to 20 meter per second. So vx can be written as 20 meter per second plus acceleration along the x component is 0. So vx is equal to 20 meter per second. So that is one finding that we have made. What is the next one? See, the next one is that it is having a component due to gravity. So ay here would be equal to g. So we can write that vy is equal to uy plus, what is a? A is 10 into t. Now since the vertical component here is equal to, 0. Why is it equal to 0? Because when the object was dropped from the car was moving along the positive x-axis alone. It had only the x component. Since the car has only the x component, the object dropped from the car will also have only the x component. The object dropped along the car will have only the x component, which means the y component of the object is equal to 0. So uy is equal to 0, which means vy is equal to 10 into t. Right, so this is what we have. These are the two values what we need. So ux is equal to 20 and vy is equal to 20. Vy is equal to 10t. Now, what is the acceleration at t is equal to, what is the velocity and acceleration of the ball at t is equal to 6 seconds is being asked. So between t is equal to 4 to t is equal to 6 seconds, what is the time difference? It is t is equal to 2 seconds, right? In which case we can say that Vx is not dependent on t, so Vx is 20. But Vy is dependent on t, it is given to be 10t and the time is given to be 2, so this also becomes 20. Now, what is the net velocity? The net velocity Vy will be equal to root of Vx square plus Vy square. Therefore, V will be equal to root of 20 square plus 20 square, which is V is equal to root of 20 into root 2 meter per second. So this is the answer for velocity. Now, what happens with respect to acceleration? See, for the ball, acceleration also is along two components, which is x component and the y component. What is the acceleration along x component? It is ax. What is the acceleration along y component? It is ay. What is the source of ax? It is the velocity of the car. What is the source of ay? It is the velocity of, or it is the acceleration caused due to gravity. Now, since the car is moving with uniform acceleration, we can say that ax is equal to 0. And since the object is moving with acceleration equal to g is equal to 10 meter per second, we can say that ay is equal to 10 meter per second, in which what is the net acceleration? A is equal to root of ax square plus ay square, which is equal to root of 0 square plus 10 square, and therefore A is equal to 10 meter per second, which gives us the correct option as 20 root 2 and 10, which is option D. The displacement time graphs of two moving particles makes angles of 30 degree and 45 degree with the x-axis, the ratio of their respective velocity. See, we did a very similar question, but back then we were asked to find out the acceleration, and also we were given the value with respect to the y-axis. So again, if we try to understand the concept here, see what is slope of And now if you think there's a how did this 1 by root 3 become 1 by root 3 is to 1 become 1 is to root 3? It's very simple. So if you take VA by VB, what do you get? VA is 1 by root 3 the whole upon 1, right? So VA by VB will be equal to 1 by root 3 by 1 is 1 by root 3, and therefore VA is to VB will be equal to 1 is to root 3 is the mathematical explanation for the same.